Hi folks, welcome back to part 3 on the contraption. This video is going to have continuity issues, I'll tell you right up front. I have a fan running because it's really hot, so I do have the, the thingy on here. These furry covers for microphones. Thing may work or may not work with the fan, I don't know. I apologize in advance, but it's hot as hell out here. I started this video off going down one road because I didn't have all the parts for the engine yet to get the engine back together. Otherwise, I would just gone right into that and we would have started putting this thing back together. So I went into other things. I'm going to show you some of the electrical stuff. I'm going to show you some of the stuff we're going to do for the forward controls and handlebars, an issue with that, and wiring. Now I have been doing a ton of stuff off camera, electrical on this. So you can see the box looks a lot different. I got rid of that stupid belt that was going across there, and I moved the switch for the headlight from here, and I put a plug in there on the top. Let me go ahead and take the top of this box off and I'll show you what I did inside there. I think it came out pretty cool actually. Okay, so you can see I got a little thumb nut if you will. Anyway, that stupid belt that was across here was holding the box in place because the only place otherwise it was held in is that bolt going down through a feature in the back of the motor. So here's with the cover off. I think that's a little bit better. Now you can see the plug and the switches over to the side. So this is what holds that cover down now. This is a Delrin rod. I believe it's 1 inch diameter. There's a stud in the top. There's a stud in the bottom, out the bottom I should say. And of course a stud behind the camera.
That's not true.
What this does is provide a standoff for that cover. Quite obvious. You see that little hole down there in the cover? I did that first. Then I lined the cover up to the box. And then I just used a long punch as level as possible with that electronic level gauge I got. Drilled straight through the bottom because at the bottom of this box goes down here to the support that goes across from one side of the frame to the other. And this is just flat steel, probably about maybe 1/8 of an inch. And that's what that belt was attached to. Now I left most of it underneath there. It's kind of a cushion for the box still. So I drilled and tapped a hole through here for M6, that's what these studs are, and then just screwed this Delrin rod in. That was before I put this top stud in. Put a nut on the bottom of it that goes up against that strap, and then I put the cover over on top here, made a mark, and then just took it back out and drilled and tapped for another stud on the top. It's kind of pulling the cover down, you know, it's kind of pulling it in. As far as the box electrical goes, the only other thing I did was I corrected the issue with the voltage regulator, the reason why I wasn't charging. They had no battery plus or B plus going to the regulator except right from that switch right there when it was mounted down in there for the headlight. I didn't realize that. I don't know why they did it that way. It doesn't make any sense because you really need this thing charging all the time. I don't like that, so now it's wired up to this switch, which is, by the way, going to get replaced. So that's the only other change I made in here. Besides, of course, you know, again, putting that plug in so we could remove the cover. It's quite obvious what that's for. You just unplug it, get the cover out of the way if you're going to do some work in here. And yeah, and then I put some rubber around the edge there because I didn't want it to chafe into the alternator wires here, or the stator wires. I'll explain this plug here in a second. This is like the definition of clutter, this entire motorcycle here. You can see that there's 2 main terminals on your typical starter solenoid. The one that's got the the split loom on the left and the bottom is your main bateria voltage coming down, and the other one is empty because I didn't want some dummy, namely me, accidentally going like this or reaching in here to do something and hitting that, and then all of a sudden the thing starts cranking and then the cam chain gets wound up around the crank and snaps, and now I got to do a case split. And remember folks, a case split on this bike, well, it ain't happening. So I'm not going to cause it either. They essentially bridged these 2 connectors. In other words, the battery power to the output, which would typically be the output on the solenoid, right here at this switch. So this switch was taking the entire load of the starter motor. And I'm not really sure why they did that because there is absolutely nothing wrong with this solenoid. The 2 wires, yellow with a red and I think a green with a red, they were just wire tied up and not even stubbed out, just bare wires. And those are the ones that activate the solenoid. So now these are hooked up to that switch. So this solenoid will go clickety clickety click and it works just fine. So now it's going to load properly through this switch, this momentary switch, which it was not doing before. I do not know what this switch is rated for. The way this thing is so loose with the contacts, I can guarantee this is not rated for that kind of current when this thing's cranking over. I put a plug on it in case it needs to be serviced or removed and replaced. Now, as far as the wiring up here for the ignition, and this also has a connector up here for the exact same reasons. Well, I already gave you a summary on the electrical. This forward control deal is going to be a real big challenge, and it's going to require some grinding, welding, fabrication, and all sorts of stuff, which is why I've got this sealed up this way. I'm going to put a second garbage bag over it and tuck it way in, and we're going to have to get welding blankets down inside here, which I've got 2 big ones. Yeah, actually 1 big one, but
that's bullshit.
We'll be able to do some welding on this frame because we're going to have to put some tabs on here and some brackets because we don't have an upper engine mount like a standard CB750 would. In this case, the kit, which is over here, is designed for a CB750F, which is not even what we're dealing with, but it's close enough. And I'll show you what we're going to have to do with this kit, but as we go along, because it's really impossible for me to do that without 2 extra hands. We're going to take this part, which is an, I don't know what this is. This is something that came with the circus bike, and it's some sort of a rack or something like that. I don't know. And I don't know what this fits. And I've kept it in the shed with all the other scrap metal to butcher it up. And that's what we're going to do because I don't know what it fits. Otherwise, I'd probably sell it, make a few bucks on it. But the thing is, I need these ears now. I actually need these little angled ears to look like a boomerang. And I need these guys, these 90-degree guys, but not the spacers necessarily, to do what we got to do. But the first thing is we need to get this crap cut off of this thing, and then we'll toss the bar, the hollow tubing part of it back into the shed. All right, so here's the idea. Take this piece like this, which I had to drill this hole out, and I had to drill that out. I drilled them both out to 7/16. This one was kind of oblong. It almost fit, so I just ran an 11 mil end mill in there and cleaned it up. But this one I just used an 11 mil drill bit centered on the hole and opened it up. Because this guy's 11 mil probably for a 10 mil bolt. This is not a straight through bolt like the bottom one. These are just to this length up here, and there's a spot apparently for the head of the bolt, which we are going to use a 7/16 fine thread. Not this one. This is a just for mock-up, a 7/16 bolt. I'm not going to use the coarse thread stuff. So this piece here, and I saved you the pain of me cutting these things off with a whiz wheel, will go like this. Now, if you look at the instructions, this is where I'm kind of going off of. This piece that I'm talking about that the lowers mounts on, this is an F model, so it's a little different, but here's your little triangle piece for the upper front engine mount that's missing on this, which it really should have. That's where they tap into on this, and it angles backwards a little bit. Well, I'm not going to be able to achieve the backwards angle all that much. This one's pretty much going to be vertical like this, in line with the angle of the frame. Because we're going to put another piece over that's going to get welded to this that comes across the back of it, which is the other part of that angle that I cut off. So this will go like this. This is drilled out for that same bolt. This will go like this. So let's slip that through too on the outside, which barely fits. There it goes. I guess I'm going to have to go to 7/16 on it. This goes through here. This will go through there and provide the bolting for that. Now, this thing will essentially, this is as far as it can go down. It can't go backwards. Okay, I have no choice but to put it here. So it's going to be at this angle right here. Got you zoomed out a little bit clearer for this. Now, whether or not that this is going to work out for him lengthwise, you know, for his length of his legs, I don't know. This is all I can do. So it's just the way it's going to be. So essentially what we're going to have here is we're going to have this piece right here that comes like this. Now we're probably going to have this slide out like that, a little bit further, like this. See how that's more parallel right here. So it's essentially going to be almost directly behind this spot right here. We're going to be able to go straight through from the back with this long bolt. This comes through this long bolt to mount this. This will essentially be the bolt that bolts this piece and this piece to the piece we're going to weld to the frame, which is this piece. And so it'll essentially do double duty.
I'll explain what I mean by double duty in just a little bit.
And so this piece here, I got to get rid of that spacer part, but this piece here is going to go something like this. around the back side of it. And at the right level, at the right height. And we'll just use this hole on this thing that we put in for that to line this up, and then we'll tack it in place and get the thing welded up. And then make sure we have the proper bolt stick out. We may have to modify this idea, but this is at least the initial genesis of it. Well, here's the back side of it. You can see that we are pretty close to that hole. It's probably a 1/4 inch overlap. I'd like it to almost match this. So what I can do is I can do a weld buildup and then just grind it back and then smooth it all out. And that'll be fine. It'll add some material. But I think that's going to work out pretty well. And it's the only way to do it. Now here's this added benefit of it. This really needs another pair of engine mounts. This is a heavy ass engine. It's bolted through down here and is bolted through in the back. There's 4 engine mount points. Upper, rear, upper front, lower front. They're only using 2 of them. Lower rear and lower front. And that is not enough. This thing is bending that bolt that goes straight through. So this bolt is kind of like this because of the weight of the motor pushing down on it. And this side's even more, visible because they got a spacer there. Let me go on the other side and show you. Yeah, see, again, you can see this thing doing this. It's going boing. You can see how that's angled out a little bit upwards. All right, so what we're going to do first is get a jack underneath this thing and loosen up the engine bolts, the engine mounts, and jack that motor up a little bit and take a significant amount of weight off of this front one. And I'm going to try to get that big long bolt out. And if it's bent, we're going to straighten it. And then we're going to put it back in, but not put all the weight on it. We'll kind of centralize it. That way when we put the uppers in, the uppers will be in a position to actually help support the engine and not just be kind of like a Fairweather Johnson for the bottom ones there, okay? We want those to be working. We don't want them to be just, sitting there looking pretty, which they probably won't because the welder is, well, he sucks. All right, as far as forward controls go, the right side is pretty much done. Move this out of the way for you so you can kind of see the whole thing. So we're bolted up to the engine here. This is your main engine mount. This would be your upper front that you would typically use with that. I think it's like a triangle plate that most of the motorcycles use. And that bolts up to 2 of those through bosses, those circular bushes or spacers that they put into the frame, weld them in usually. And the way this works is you have that bolt for this lower that goes through the back side. It goes through this plate and the lower bracket. And as you can see from the clips before, I welded this 90-degree bracket to the frame. So at least this gives us 75% of the engine mounts instead of only 50%. 25% is a lot. So with this stud, that's why this is behind here. Otherwise, I could have just gone from here to the bracket and called it a day and just made this match that. But what if you took these off? What if you said, you know what, I don't want the lowers anymore, or the forwards, I keep calling them lowers. I don't want the forward controls anymore, we'll just go back to the foot pegs. And so now we still have an engine mount plate there. So that's really what this is for. Now there's another hole right here in these forward controls. We're going to go ahead and mark that and take them off and drill and a through hole for just, I think that's probably an 8 mil. I'm pretty sure that's what it is. We'll figure that out and just put a short bolt and a nut in there. Or I might even tack weld a weld nut on the back side of it because all that's got to get painted black anyway. And then just put a bolt through, I'm not sure yet. And it's strong as hell. Let me tell you what, there is no problem with strength on this. The forces are going to be this way anyway. That ain't going nowhere. I know the quality of my welds as far as visually basically suck. but none of my welds ever broke or break. You know, the whole sidecar rig deal I've explained before is all done with that welder. So a little grinder and paint makes me the welder I ain't, but there is definitely an abundance of weld in there. My stinger will not fit down inside here. It's always the case that my stinger is too damn big. So I can't get it down in there. So we came across the top, we came across the bottom, and all the way up the side with a couple of runs, like a root and a couple of filler passes. And that's going to be just fine. There's no way this thing gonna bend. Because, you know, there's a lot of stick out here, but, you know, I can't engineer that out of the equation. The forward controls have to be forward and out because of the engine case. I think it came out okay. I'll show you this side. Like I said, the welds, I can only do so much with this Clark welder, but it does get good penetration on material this thick. Excellent penetration. I am confident that nothing is going to break up here. And since we've got such good contact with a big-ass bolt, a BAB, and another somewhat big-ass bolt up here, I think it's going to work out pretty well. So this would be about at this level here, something like that. And, you know, I almost forgot two important things that I wanted to share with you right now. Because of those two plates back there, the way this is designed from the photos, that big bolt is not supposed to go through any bracket. So that's calculated full length from there to there. So when we add the thickness of these two plates, we're consuming about, I don't know, 3/8 of an inch. And so we have 3/8 of an inch less thread engagement into the end here, which I'm not too happy with. Now, what I'm going to do to mitigate that on that side is simply use longer bolts. I might use them on this side too, but I'm not sure yet because I think this is out a little too far to the side relative to the engine case. I think it needs to come in about 3/8 of an inch. Essentially, the 3/8 of an inch will allow the bolt to penetrate further into this foot peg. How I'm going to do that, I'm not sure yet. I'm going to try to fixture this up in the lathe somehow because this has got to be perfectly square on the backside and then compensate for it that way. I just have a feeling that this one just needs to come in a little bit more. I don't want it too close to the engine case, but I don't want it that far away. So that's probably what we're going to do to mitigate this side. And when we get to that side, I'll show you the challenges on that in regards to the length of the bolt, which is why we're just going with a longer bolt, which I have to go out here today and get some. Okay, this is basically the final configuration of the mounting of the forward controls. Naturally, they're not hooked up or anything. We've got a lot of work to do on that still at a later time. There'll be a linkage. I think I mentioned 5/16 is what they recommend rod with threaded ends, and it goes into not a Heim joint, but like a swivel joint, and 5/16 24 thread pitch. What they recommend is you just cut these, the ones that come on the bike, and you point them downward so this thing will articulate it the appropriate direction. So you can see in this case it would be like this. Doing this crap to move that thing. If this thing was pointed downwards, in other words. But I don't want to butcher these in case he doesn't like this. So I ordered a used one of these and a brake lever for this particular 78 model engine. The 77 and 78s are a little different than the earlier and later ones. It looks right on the pictures. I don't have them yet. And we're going to butcher those instead of these. This will be pointed straight down to articulate with a rod to actuate this thing in the appropriate direction. Same thing for the brake. Now, as far as how this worked on the left side, there's a couple of differences from the right because the engine is set in the frame that way. It's staggered over to the right side, which is typical for these because of the offsets of the sprockets in relationship to your rear wheel. So I had to make a spacer. I forgot how wide or long this is, 1.25 inches or something. It's zinc plated, so it's not going to rust. And of course, the nuts that I did for the inside of those 7/16 bolts, those are kind of special as well. I don't really know what goes inside here. I'll show you a little B-roll of what that space looks open. I think there's supposed to be some sort of like a flat piece that goes inside here, or some sort of a different nut, if you will, quote-unquote arrangement. As you can see, as I said before, it doesn't go straight through. So it's definitely captured in this one particular spot. So I had to take this nut and turn it down on the end and also mill the flats a little bit so it fits into this space right here. Without that, it wouldn't fit in there, it would kind of jam up. And it kind of tapers down in the corners here, which is why I turn these down a little bit so they fit a little bit better. And of course, these are zinc plated as well, so they're not going to rust. I got full thread engagement on both and then some. And they are Loctite, blue Loctited as the instructions say. Here's that M8. I did thread this instead of putting a nut on the back. I have the nuts. I'll probably put them on more for aesthetics than anything else. But that's good and tight, you know, German torque spec, good and tight. Now on this side here, I really wanted to have this one, as opposed to that one, pulled in. I wanted this one to be pushed out a little bit, by a 1/4 inch. It just felt better and looked better. I could have done that by increasing the length of this spacer. But then I would have run into thread engagement issues and I would have had to source another bolt. So I figured the easiest and quickest way to do it for adjustability is just machine another spacer, 1045 steel, zinc plated, 1/2 inch hole in the middle. That spaces this out a 1/4 inch more, and I think that works out a lot better. And again, it's adjustable. If he doesn't like that or it's not out far enough, there's plenty of thread engagement in here. Because this is a longer bolt. This is like a 6-inch bolt on this side. I got it at the hardware store. 1/2 inch 13 threads is what this takes. And we can always do some adjustability on that. But I think it's going to be pretty good the way it is. And again, like the right side, it is rock solid. So those are the various, you know, slight changes I made between the two sides. But I don't think we're having any problem with this. And now we've got 75% of the engine mounts engaged. I think that's really going to be a lot more solid for this engine. Now when we take these guys off, if we take these off, if he likes the way the lowers, I'm sorry, the forward control, I keep calling them lowers. I don't know why. The forward controls work, which I'm sure he's going to want to lose these guys. These are basically garage butchered spacers on what I assume is the original long bolt that does go through from one side to the other. When this comes out, it'll even be longer. So we might end up taking this original bolt, cutting it down and single point threading the appropriate thread for that nut over on the lathe, and then making that a lot nicer where the head of the bolt on that side goes up against its mating side of the frame with a washer, and the same on this side, missing of course the two original or the 2 foot pegs that are on here now. And I think that's going to work out pretty well. What we're going to go ahead now is just close this part out as far as fabrication goes, because number one, we're pretty much done with this. And number two, it's a lower priority than the engine stuff. So let's go ahead and just move over to the bench. We'll look at the valves here in a little bit, as I said. We'll look at the cylinder block now. I'm going to unwrap it. We'll take a look at the honed bores. Remember, everything's already been measured, but I have honed them and hadn't shown you that yet. And I'll kind of do a comparo of before and after. And we'll go in here and get the piston ring end gaps done, and I'll show you a little bit of that. Then we'll take a look at the valves. Then we can move back in if there's time in this video, and we'll start loading stuff back up on the engine and get the reassembly process going. Well, this is the top ring, and it says in the instructions to put the mark upwards. In this case, it's an R. And the service manual talks about putting them in the orientation that the piston skirts would be in. So since we have our wrist pins going this way, the skirts would be this way. I don't have a piston to shove them down square. So all we're going to do, and I have this all oiled up, we'll just scale them in down a little bit. It doesn't say in this particular model, like the Kawasaki manuals would tell you how far to put them as far as how far down into the bore. We'll just kind of scale them down like, I don't know, 10 mil or so. That's pretty good. Okay, the standard is 0.2. That's 0.20 to 0.40 millimeters. That's what we got here. So let's try a 0.2. I don't expect these to be out at all because the bores are perfect as far as their standard size. And there's no taper to them hardly at all. So this should, and I've never seen a stock set of rings, a package set of rings for a standard come in with needing to have the end gaps adjusted at all, ever. Let me go ahead and turn this around since I put that ring end gap in stupidly. So now we're over here for number 1. 0.2 fits, no problem. 0.4 does not, which is good. So it's probably about 0.35. We don't even have to measure it. As long as the 0.2 fits, I'm more concerned about too tight of a ring gap than too loose. Because the standard allows you up to 28 thou, I think it is, with that would be a 0.70 millimeter, which is huge. So this is again 0.2 and 0.4, perfect. So this top ring for number 1 passes without any trouble whatsoever. All right, I turned around number 1 less stupidly as far as the orientation of the ring gap. And this is the second ring. Rinse and repeat. 0.2, that's the same standard for the second ring. And that fits with some clearance, no problem. It's not dragging at all. And 0.4, which does not fit. Recheck. And again, 0.4. Yep, so those are good. I'm going to do all the rest of them off camera and put these back in the boxes I came out of and labeled this one number 1. Normally I do that because these cylinders are usually all over the page on these old bikes when you're just kind of re-ringing them and kind of winging it. But in this case, since they're all right almost dead nuts to standard, it probably doesn't matter, but I'm just going to do it anyway because that's the way I always do it. Really, tightness is way, way worse than looseness because, you know, these things start binding up when it heats up. That's what the ring gap is there for expansion, to allow expansion. And if they close up that gap, then you'll end up seizing that ring in there and burning up the cylinder walls and all that bad stuff. Now, speaking of cylinder walls, I have not done this yet, but I'll show you a before and after of the way it looked before I honed it and the way it looks afterwards. We'll just use number 2 here. I'll go ahead and interpose the before with this after, but you can see this is how it looks like after honing. Now, there are a couple of very small vertical lines in different parts, and number 3 in particular, I forgot where it exactly was, probably from that broken ring. You can see one in number 2 here, and that may only be from my dial bore gauge, just a little surface artifact. That's probably what that is, but there is one on number 3 here that is definitely not a surface artifact. Yeah, so there you go. You can see it right there. Essentially, it's on the back side, because I'm facing toward the cam chain tensioner side. That is undoubtedly from that piston ring, the broken ring. But even without gloves on, I can't feel that. So again, it's more of a surface anomaly than anything to be concerned about. But yeah, I think the honing came out fine. I've got about a 41 to 44 maybe degree angle. Cross hatching looks pretty good, and I'm perfectly happy with that. This is the way I always do it, and it's always worked before, so this is the way we're just going to continue to do it. A couple of quick side notes on what I just showed you. For each bore, I oiled the bore up with some motor oil and oiled the rings, especially those compression rings are pretty tight, especially the top ring. And so even the oil rings, I oiled them up as well as the bores. Now, the 10 millimeters down inside the bores to check the ring end gap is an arbitrary number because there's nothing in the service manual, and only because the dial bore gauge doesn't lie and there's virtually no taper and outer roundness to these cylinders. I mean, it's within tenths. So it doesn't really matter because the dial bore gauge said so, where we put those rings in here to measure the end gap, because the bores are parallel. Now, if they were out, absolutely, I'd push them down about halfway, maybe even try more than one spot. You know, if they tapered narrower at the bottom of the movement of the stroke, as far as that distance, then we would absolutely want to make sure that at the bottom there, they are not too tight. But again, the dial bore gauge doesn't lie, and these things are parallel and round. So I don't have a problem with just going 10 mil in. It's more convenient for me, and it's just easier to see for you guys. All right, folks, more bouncing around just like the other videos on this thing. Now, that's not my fault. I mean, I got to wait for the parts to come in. These should be the valves so we can work on the cylinder head. Well packaged so far. Although I do hate these peanuts. Well, I would prefer it if they had kind of separated them a little bit, but do a little comparo. Here's number 3 intake. Oh yeah, okay. The ones he sent me were just clean. Cleaner. Here's an intake, there's an intake. Yeah. The difference between the older ones and these more later ones, and I mean the original, the earlier CB750s, they got a really wide space here where the keeper goes. Jeepers Creepers. There's your keeper. And those are apparently the more desirable ones. I guess they hold better. There is some literature or some comments and, I don't know, some other bullshit, I guess, online about these things slipping and dropping a valve on these, I guess you want to call it later, CB750s, but I guess it's not too common. The groove is really the important part, and one of these old ones here, the grooves are actually, most of the old ones, the grooves are kind of tore up, so we may end up just using all 8 valves from this engine that came in from Fleabay. Let me put this back in the appropriate number 3. Faces look good. That's just one, of course. Here's an exhaust. And there's the slot where the keeper goes, the groove. The tips are a lot nicer too. Yeah, so I think we're probably going to end up using all the valves, I bet, from this donor engine. I mean, this exhaust ain't so bad. This is number 2 exhaust. But you know, the tips are kind of screwed up from all that wrapping in there. I'll do an evaluation in more detail off camera, but my gut feeling is we're probably going to end up using most, if not all, of these that came from eBay, because they look pretty nice. They look damn nice, actually. They may not even need any grinding or anything. They just might need some more cleaning and then just lapping. I don't know if I have to do the seats even on the head. The seats look really good. So if we lap a particular valve to a particular seat and a particular spot, and it's good, it seals, and we test it and it seals, then Bob's your uncle. So there you go. Now let's talk about these handlebars really quick. That's the reason why there ain't none, because I wanted to put those handlebars on that are right there in that pile, and they're too big. That's a 7/8 diameter hole. The old ones were 7/8. These are 1 inch. There's the part number. They came from JP Cycles. Now I contacted the owner and I said, hey, your handlebars are 1 inch. They're too big. And he said, well, I ordered 7/8. But the first ones that he ordered, he said, were stolen en route. And I remember after he said that, he told me that story. So he said, in shipping, the first handlebars were stolen. And so he contacted JP Cycles. And they sent him out another one, exactly the same part number as that. Brought him over here, but I haven't been able to get to him because I've been doing with this crap. So the other day I pulled him out and took a look at him. And then I let him know they're too big. And he's like, well, I ordered 7/8. So I gave him that part number, took a picture of it. And then a little while later, a couple hours later, he says, I need you to please take a picture of like some sort of measuring device. They need proof that they're 1 inch. I go, okay. So I took my Starrett dial caliper on the end of the bars. I laid them over there in the concourse because it was convenient. And then just snapped a pic and sent it to him. And about half an hour, 45 minutes later, he said, now they want a picture of you measuring it, but they want to see the bars in the background. And I'm like, what the hell is up with that? So obviously they're thinking, oh, he just took a picture of a piece of chrome tube and he's trying to get one over on us. And so I said, all right. So then I did that. And so I have another picture that I'll show you here of just the whole bars wrapped up in the plastic again. And I sent that to him. And then the next day I heard back from him and he said, I just went ahead and ordered another set, but now they want a picture. They want to see the part number. And I go, this is getting out of hand. That's when I asked him, where did you get these from? And he said, JP Cycles. I can't do nothing with the bars. I can't do nothing with the cables. I can't do nothing with nothing. I don't have the 7/8 replacements. And like I said, JP Cycles is giving them all sorts of hassle and static on returning those. So that's it. I'm not going to say any more about them. All right, guys, continuation on the contraption here from a little bit of a break. You may have seen the video I put up about us being out of town for 9 days. And today's the 16th, so we got back yesterday the 15th. I'm getting back into it today. Pretty short day because I've had other things to do, but we're going to at least update you as to where we're at. I've gotten all the new piston rings installed on the pistons that are in here. As you can see, as I've told you before, these are probably aftermarket. I'm almost certain they are. I'm overall happy with the measurements as far as the side clearance, you know, between the ring lands and the rings themselves, except for the second compression ring, which is extremely tight. It's not tight in regards to the feel. I mean, these things move around just fine. There's no binding, no nothing. They feel perfect. But as far as what the service manual says, that is tight. Now, it may be perfectly fine for these aftermarket pistons, though. Who knows what the hell they are as far as brand. And a lot of times you really have to go off the information that comes with the pistons themselves in order to make sure that you have everything's within spec. I'm just going to leave it because I got no other choice. I've got really no definitive way to go either way to determine whether or not I needed to change the pistons out or change the rings or both or something. Again, they don't bind up at all, but as far as the numbers go, the second compression ring is tight. Remember, the second compression ring was the one that was broken on number 3. I doubt that has anything to do with that. That has to do with the installation part of it because the piece was laying down in here. So I'm not thinking any ring seizure whatsoever because we have perfect, you know, the perfect cylinder block as far as no scoring or anything. We're going to run it, so that's the best we can do. I pulled these valves out. This is the Bag O valves, that came from eBay, and I just glanced at them before I left on our trip, me and the dog. And so I went down my neighbor's and I ground the faces. I just touched them up just to clean them up.
It was at this moment that he knew. He f***ed up.
All right, so it appears that I screwed up again. And as you know, I don't hide my mistakes, but I'm not 100% sure it is a mistake. I can tell by this way. If you CB750 guys out there are throwing your crushed old Milwaukee beer cans at the screen, you know, the ones you crushed on your forehead, then I know I made a mistake. Apparently, you're not able or supposed to grind the valves on a CB750. They're supposed to be, allegedly, there's a paper-thin hardening layer. I wouldn't call it nitride, but it's kind of something like that. I don't know what it is. On the faces and I assume the tips of the valves as well. And you can't grind them. If you do, allegedly, or what I'm reading online now, they're so soft that they wear immediately. Like one of the guys wrote, they'll wear like lightning. Since I can't find any contradictory information that says that's BS, I gotta go with that. You can do a light lap, which is essentially just to match the face of the valve to the seat and to prove that you have you know, a circumferential or completely around the face contact with the seat. And that's it. And I tried that with the valves that came in from eBay and it didn't look good. So that's why I chose to grind them. And you know, all used valves, I'm telling you right now, especially smaller valves, are going to be slightly bent. You know, they're going to have a slight bend to them from all the years of use and heat and cool cycles. And, you know, usually you have to grind them to make sure that they're true. And that's exactly what I did. So I'm reading online in different forums and stuff that you can't grind these valves. That's the whole point here. I can't find any contradictory information that says that that's BS. The only thing I can find is just that you can't grind the valves. You have to replace them with new, which I wanted to do originally, but I couldn't find any. Now I am ultimately going to replace them with brand new valves. So you guys, you CB750 guys can go ahead and pick up all your crushed beer cans that are laying in front of your TVs or computer screens. Toss them in the recycling, please, all right? And we are going to put new valves in it, but it's going to be a little different setup than the 78 valves. It's too complicated and lengthy to get into in this video. I'm no CB750 guy. I don't profess to be a CB750 guy. I never said I was. And I never intended on getting into this engine this deep. But unfortunately, this is the situation I'm in, and I'm doing the best I can. So we're moving along with it. So you just have to wait for video 4 to see the resolution of this. All right, folks, that's pretty much it on the valve drama. We need to move on. We need to recover from our mistakes or alleged mistakes. But, you know, I'm not going to give up now. I'm going to keep moving along with the blessing of the owner who said he wants to do exactly that. So let's go ahead, and I'm going to change my mind on putting the cylinder block on when the cylinder head is ready. Let's go ahead and just do that now. That's kind of complicated to do sometimes on these inline fours. I've never done it on a CB750. So I'll kind of give you some time warp, and it'll be voiceover most likely because I really couldn't talk while I was doing it because pretty much I don't know what I'm doing on this. So I'm learning as I'm going. But we got it done ultimately, and you'll see how we did that, how I did that here in the forthcoming clips. And I'll explain, I'll make it as brief as possible, and then we'll go ahead and close this abomination of a video out. On any engine that I do, I always replace the knock pins or the dowel pins. That's the part number. And we're just going to make sure that these fit right. When I tried the first one here on the left side, I wasn't too happy the way it fit, so I ended up taking it back out and re-cleaning the counterbores that those fit over that stud on both sides. These fit on the front left and the front right only on the crankcase, and there are a matching pair where the cylinder head aligns to the cylinder block once it's installed. Going to go ahead now and do that tensioner roller that goes on the back side. And I cleaned up the pins that it rides on really well with some 2000 grit and cleaned them off with a rag and some brake clean. And I put some, as you can see, some assembly lube on there. I don't use assembly lube on everything. And when we get into the cylinder head side, I'll explain why, in particular when we're putting the valves in. But this is a little fiddly because you kind of get it in there and things just don't want to line up right. So I've accelerated this footage to make it a little bit more brief. And then once you get everything aligned, you got to put these two rubber dampers on the end of the pin that goes in the backside. And then that goes underneath the gasket, the base gasket, which is why I'm doing that now before the base gasket goes on. The only things that really go between the crankcase and the cylinder block are those two knock pins I showed you before, the locating pins, and these two O-rings that are on the supply side to go over those two center studs. And of course the base gasket. So right now I'm just getting those O-rings in place. Next is the base gasket itself. I figured the writing on the base gasket would have to go down. I've never seen them up, where you can see a little bit of the gasket sticking out on these applications. So that's the way I did it. And again, it goes on top of everything else. All right, so this gets a little tricky here. I'm going to oil up the rings on the two center cylinders, which is 2 and 3. They are sticking up right now. The problem with these motors I've found is there's not a whole lot of room to put the cylinders all even like you see in service manuals. And they have special ring compressors, I guess they use at the factory to get that in. I have my own setup, which I'll show you here in a second. It's pretty simple. And I do that on 1 and 4 as well when we get to that point. So I just have some tampons down there. I'm trying to protect the base gasket as much as possible. And unfortunately, you just get a little oil on it, but I don't think it'll be a terrible thing or a deal breaker. This is bound to be the most controversial part. Now, what I use for ring compressors is simply hose clamps. I have 2 sets of 4. These are the sized ones for 750, and I have 4 for 1000, because that's typically what I do. I found these to be the best. I do have commercial ring compressors. They just don't work in this application because they're too wide. The stroke on these motors is too short, and as you can see from number 4 right there, when you bring these pistons down, and if they were all level, in fact, a portion of that skirt's going to be down inside the crankcase. And then you add the fact that the cylinder block, the bottom of the block extends down in there. There's just not a lot of room to get anything wider in than about the width of a hose clamp. But the hose clamp is just barely wide enough to cover all the rings on each piston. So it's very, very fiddly. The middle ones are easier because I have a little bit of a helper that I put in there, and you'll see that here in a minute, but still tricky. All right, so this is what I use for the cylinders that I can actually use them on, which typically I do the middle ones first because they're harder to get at. These are just, it's just plastic, the molding you can buy at the big box store to trim out. It's like called brick molding. And I machined these out with a slot years ago to get these things to essentially go underneath the pistons and kind of hold them still and level when you're putting the cylinder block down on top of them. And as I described before, because of the short stroke on these motors and the depth of the piston skirts that go inside the block, it's impossible to do it on all 4 cylinders, even with them even. There's just no place to get them. There may be some sort of special tool or something that the factory uses. I don't know what it is.
But what I do is I get the 2 center cylinders, at least, of pistons aligned and bring them down so they're just touching. It helps keep them from rocking. And that way, once I get the rings aligned and get it all the way I want it, then we're golden. Now, I tried to get it in from the backside here so it wouldn't slide away because of the taper on that cylinder, on the crankcase. But they won't fit in this one, so I just have to push them in from the front and just hope for the best, which they ended up working fine. I wish I could get them in all 4. That would really have helped out a lot, but unfortunately, you just can't do it on a lot of these inline 4s. Here's where the rubber meets the road. I need to accelerate this clip because it's pretty long, and I'll kind of cut it up a little bit for you. Obviously, I'm slipping this thing down, and there's a mistake being made right now, and it's a big one, which I'll identify later on. But this is really how I do it. I mean, this is how I do it every time. Get the cam chain, the wire and the cam chain pulled up through the center, and then just get everything lined up. And those 2 center cylinders just go 1, 2, 3, boom, 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 no problem. They go right through. You got to keep that damn tensioner roller arm out of the way. It does like to fall backwards, and a little feature of it kind of catches on the cylinder block itself, and then you're like, why didn't this thing move down? And the next thing you know, you have to lift it back up to clear that thing, and then you lose your piston rings, and you got to reset everything. So I just keep looking, and you can see there, I just keep adjusting, and then I'm disconnecting or disengaging the hose clamps on those 2 center cylinders and banging it down a little further. And once that's down that far, then you know you got it. You just take the hose clamps out. Cylinders 1 and 4 were particularly bad in this case. And what happens is when you get 1 in or you get 4 in and you tap on the cylinder block like that, and I never use a hammer, by the way. I only use my fist because I want that feedback, what it's doing, because otherwise it's how you break rings. And it just was a real pain in the butt because once one goes in, the other one rises up and kicks out. It just took forever. And the rest of it's a matter of just banging the thing down evenly. Remember, everything's oiled up real well. So again, I'm tapping it with my fist because I want to feel that feedback to get the thing down and seat all the way. So a little wiggling, and here's where that dang freaking tensioner likes to hang up. You got to get that out of the way and just tappy tap tap with your hand, in my case my fist, to move that thing down and get all the pistons moving into the bores far enough. Make sure everything's clean, everything's aligned, and just take your time and get everything to where it needs to be. And so I just really just go slowly, and if there's any resistance whatsoever, I stop, try to figure out what it is, and at that point I can remove these hose clamps, which are now bottomed right down the base gasket. That's the problem. There's just no room in there for anything wider. And so, I mean, you can get the pistons for 1 and 4 up higher by cranking the crank around, which lowers number 2 and 3 and kind of evens them out. The trouble is you can't hold it there. If there was a way to lock the crank, like some sort of a tool to put on there and lock the crank in a particular position, that would help out immensely. But I have yet to figure out a way to do that besides using a vice grip on that nut on the point side there where you typically bar the motor over from. And I'm really not willing to do that because I think it would mar it up. And if things slipped off in the middle of doing something, everything would come crashing down. So I'm not really sure the best way to do that. But this is the best way I've ever come up with to do these, using the hose clamps and just tapping it down in. And eventually it goes. And so that's where we're at this point. We're going to get her all the way in. All right, so what was holding me up was one of the oil control rings wasn't completely captured by the hose clamp on number 1, the bottom oil control ring. And that's why I don't force things, because I want to see what's going on. So I just simply had to readjust that hose clamp to capture just part of that oil control ring, because the piston was kind of in a little bit crooked at that point, as they typically are, until you get them further into the bores. Now, once I cleared that, no problem. I was able to get the thing to slide down because now all 4 pistons are well into the bores themselves, and it's a matter of just wiggling it down because you want to make sure you get the alignment pins articulated with the cylinder block itself, which is a little bit of a challenge. Now, I didn't show this, but before you put a cylinder block on like this, you want to test fit those pins. And I had to clean those counter bores out in the bottom of the cylinder block a little bit more. They weren't quite slipping in as easy as I wanted them to. So that's what I ended up doing off camera. Because remember, one of those was so seized in, I had to machine that out. And I just never got around to finish cleaning up the bores of those counter bores. So now we're at a point where we're getting her down, and I'm saying to myself, oof, man, this was a tough one. I'm glad this is over. But it turns out it wasn't exactly over all the way. And you'll see here in a second why. I have some spacers and two nuts across from each other diagonally just holding the block down. I want to hold the cam chain and just spin this thing around to make sure nothing's binding. And it feels good and smooth. I mean, there's a certain amount of resistance because you got them piston rings pushing against the bores. So I do this a bunch of times just to make sure everything's good. And at that point, I'm pretty much figuring that I'm done. But it was not to be. As you can see, the block is back off. This is not a shot from before because some dummy forgot to put the big O-rings on the bottom of the cylinder block itself around each cylinder. So now they're in, and now I got to do it all over again.
All right, folks, that's going to be it on this video. Hope you got something out of it. As far as learning anything, I'm not really sure because, like I said before, I'm not too sure what I'm doing on this. But I am certainly learning something. So if you want to see more on this, the next part, of course, will be part 4, as I said. We'll hopefully get this thing up and running and proven out and move on to other stuff in that video, and hopefully get, as far as the videoing goes, we're going to get that done in part 4. We just have to. I just can't keep going along with this thing. In part 4 also, we're going to work on the linkages for the forward controls. The handlebars you can see are up there. Maybe you can see, I don't know. And we're going to go ahead and get them all hooked up and do the cabling and so forth. And I really need to get this out of here. I really want to get the Sabre in and get going on it. Plus I still have a CB750 carb rack that was shipped in that I haven't even touched. And I've got another gentleman that I've done some work for before who's got another CB750 that he reached out to me to do some work on. And I had to put him off a couple weeks. So I've got stuff rolling, and I got to get this sucker rolling that way and not this way. So if you want to see more, you know what you need to do. Stick around, like, share, subscribe, ring the bell. You get notified when I put more crap like this up. And as always, thanks for watching. Don't just repair, restore. We'll catch you on the next video.